Right, right. Because they're straying from the original premise of the show, which
Right.
is just a
Like
fun show on a low budget.
crotchety old man wanders around the universe in a phone booth. We're really looking for like authenticity and historicity here.
Apparently, it's the same people. Like when they start nitpicking the Hitchhiker's Guide, I'm like, uh, come on.
Yeah.
Clearly not
Well,
seeing the forest for the trees.
I mean, I know the concept of, well, actually has existed for as long as humanity has,
That
but
sounds accurate. Yeah,
now we have the internet.
where everybody can actually everyone else.
Right. And it's to massacre the great Huey Lewis quote, it's hip to be contrarian.
Quadrilateralian?
I have no response to that.
There's no way to have a response to that. Are you familiar with the Outcast album ATLians?
I probably
Yeah. Now
I certainly know it by name.
it is one of those album titles that I stare at and I'm like, not sure how I'm going to say that out loud. Gonna try though.
I think that's the only way is to do it letter by letter.
I think it is as well. It's kind of like the great debate of AMI versus Amy for
No,
AWS.
that's not a debate.
It's a
No, it is
debate in the sense
absolutely
that there is a contingent of people who are wrong.
yes, and they probably all belong to the Flat Earth Society because that's the level of wrong we're talking about.
Yeah, it sounds about right. The flat Earth theory was actually one of the clues in the New York Times crossword on Sunday or Saturday, one of the two.
I haven't done. I used to go to their. I think that was free on the website. They
Yeah.
would only do like one free one a week or something.
Ah,
So I used to do that, but then I stopped doing that, and that's my crossword puzzle story.
that's your cross to bear, as it were.
Oh come on, I'm not ready for this.
It's too early in the morning.
Sorry,
Sir,
we're sued.
sir, it's 8 p.m. I meant what I said. Oh, I'm trying to get this sickness out of me, and it is
Yeah,
not agreeing with that idea.
you seem better than I was fearing, but then as soon as you said you went to breakfast, I had a glimmer of hope. And then I saw the despair writ across your face, and my hopes were immediately dashed.
The trip out to breakfast was mostly because I didn't have the energy to say no.
Right.
I had 3 children all begging me to take them out to breakfast, and saying no and dealing with the tears and frustration was not, I just did not have that level of energy. So I caved immediately and said,
You
fine.
realize that like 80% of your stories about raising children sound in tone and tenor as though you are in a hostage situation.
That's what raising children is. You're a hostage to these small humans for at least 18 years minimum.
And every once in a while, they just get you sick.
that's
This is like a reminder of who's in charge here.
I don't need a reminder, but they give it to me anyway. Oh, well, I need to shut down and reboot my systems at some point. But I mean, get some rest at some point. So maybe we should do the thing with stuff.
We should.
Hello, alleged human, and welcome to the Chaos Lever Podcast. My name is Ned, and I'm definitely not a robot. Seriously, how could I not be a human being with my face holes leaking so much fluid? Oh, that came out wrong. I, like many pseudo-sentients, can get imbalances leading to less than optimal functions like sneezing or whatever the kids are calling it these days. Snoozing, I think I heard that on the TikTokers. As always, though, man, machine, or mineral, bacon does help, and I had my helping this morning. So, let's do this. With me is Chris, who is also here.
A very safe distance away from whatever is going on that side of the screen. Because yikes.
Yeah,
I
unfortunately.
mean, no, hey buddy, you look great.
Thanks.
You look great.
I feel great. You know, with quantum entanglement, I could probably get you sick through photons or something.
I would prefer you didn't.
but it's an
If that's on the
experiment.
table,
You must do it for science.
science is always so mean to me.
It's not just you, if that makes you feel any better. Let's talk about some tech garbage, shall we?
We shall.
And, good thing that mine was the main topic this week, because that's going to be interesting for everyone. I think I can make it through it. But feel free to jump in with any anecdotes, or if you see me just collapse in my chair, just pretend to be me for 5 to 10 minutes, and I'll try to...
I was actually just going to close the screen and let you flail, but all right, your idea sounds fine too.
Oh, I appreciate that. You're a trooper. So as promised last week, we're going to talk about SmartNICs, because you want to know more about SmartNICs, right? Right.
Yeah, last week's promise was more of a threat.
And I'm carrying out that threat. Who's the hostage now? All right. So, as always with one of these things, we're going to back up a little bit, take the longer view. Since the idea and the concept behind the SmartNIC isn't exactly new, and they're not even called SmartNICs anymore because naming is hard and nothing can stand still. But
also, it sounds like an insult from a 1940s gangster movie. Yeah, you're a real smartnik, are you?
yeah, see here, courageous. Oh, geez. Courageous cat. Anyway, wow, that threw me through a loop. Took me back about 30 years, maybe more. Anyway, I'm not immortal. So I thought, because hardware in general is going through a bit of a renaissance period at the moment, since we're starting to hit the limitations of what software can do with the current batch of hardware we have out there, I thought it'd be nice to dig into how NICs have changed over time and how they're going to change future server architectures. The humble Network Interface Connector, or NIC, has been around since the advent of the local area network and technologies like ThickNet with BNC adapters and vampire taps. Did you ever have to deal with any of that?
I have done a number of plumbing vampire taps. And just to wind back even a little bit further, I always, until this very second, thought that NIC stood for Network Interface Card. So I got great joy out of thinking that we were all saying Network Interface Card.
Yeah.
And, thanks a lot for ruining that for me.
I am here, if not to ruin some things, then at least everything. So, yeah, we go way back to the old days with these old physical medias up to the current generation of fiber-based connections that are running at like 400 gigabits per second plus. I think 800 gigabits is the next supported format, though I don't know if that exists in the wild.
Just an insane number to even contemplate.
Isn't it, though? I think Broadcom just released their, I forget which chipset it is, but it's going to be supporting 800 gig line speeds in their latest ASIC, which is...
Because you need that.
Somebody needs that.
Yeah.
That somebody is going to be, the Azures and AWSs of the world. It's definitely not going to be you and me running our labs out of our basements.
If I don't have that in my desktop at the end of the year, I'm going to be furious.
You're always furious. It's your secret.
That's true.
So, like you, for the longest time, I did think that NIC stood for Network Interface Card because in the early days, a NIC was implemented through a physical card that snapped into a bus on the motherboard. Now, in the very early days, that was through the now defunct ISA bus, which was replaced by the PCI bus and its various extensions.
ISA, talk about time warp.
Yeah, well, when I was going for my A+ certification back in 2001, I want to say, ISA was still very much part of the architecture and you had to understand it. And fortunately, that is no longer the case. Most modern systems, desktops, laptops, most server motherboards have a NIC integrated into the system board itself. It's still a separate chip on the board somewhere. You can look at all the different chips and you can find it, but it no longer slots into a dedicated card. It except on server systems where you usually have a built-in NIC, and then you also have additional network interface controllers on a separate card that goes into the PCI bus. The original mission of the NIC was to provide a physical connection to the network media at layer 1, and it would use an ASIC with very limited functionality. We're talking some basic queuing, maybe a little tiny bit of buffer memory, and some drivers that were supplied to the operating system that told the CPU how to talk to the NIC. That's it. It's a real simple card. But because we can't leave simple alone, we had to make it more complex. And we
Right.
did. Part of that was because the CPU was now in charge of all network communication processing. And that includes stuff like traffic control, retransmits, establishing a TCP session, doing encryption and decryption of packets. When network speeds were like 10 megabits per second or less, and network utilization overall was relatively low, systems weren't always chatting away to each other like they do now, that arrangement of having the CPU in charge of everything was fine. Over time, speeds and feeds for the network increased tremendously, as I mentioned, 800 gigabits per second plus, and the CPU would easily be overwhelmed trying to manage all of those network connections. And that's especially true for any server class systems that were functioning as a true server to potentially hundreds or thousands of clients simultaneously over the network. And it wasn't just the speeds that changed, it was also the general architecture of the system, because this thing happened called virtualization. And now a single physical box could be host to tens, or if you really wanted to push it, potentially hundreds of virtual machines, each creating one or more virtualized instances of a network controller. If things were tough for the CPU before, now they were totally unmanageable.
Yeah, it's kind of funny because you get in a situation where the CPU is completely buried in network transmission requests and therefore can't do any CPU requests.
Right. It can't do any actual work, so we had to do something about this. And I'll get back to some of the other things that happened to the network and software-defined networking. But in response to some of these demands, the capabilities of your humble NIC expanded. And one of the first additions was the implementation of direct memory access, which allows a device other than the CPU on your system board to move data between the NIC and system memory. So that would typically be something that the CPU would be responsible for doing, but we could offload some of that work by implementing DMA. Now that required more logic on the NIC, but it lowered the overhead on the CPU, which was, a good thing. And it was the beginning of the trend where the NIC would become smarter to free up the CPU clock cycles to go do compute things instead of networky things. And the next one...
it's the same idea as graphical cards, because graphics used to be directly on the CPU as well. And then people looked at that and were like, well, this is a waste of the CPU's resources. It's not exactly designed for this. It's not excelling. It's getting it done, but let's do this better with a more specific chipset.
Exactly.
You pull all the GPU stuff in, and then all of a sudden your graphics are flying and your CPU back to being the generalist and traffic cop and handling the system from a central processing area, some might say.
Precisely. And the same thing happened with sound cards. There was a period of time where CPUs were handling all of the audio processing. And again, that's not what they excelled at. It's a general purpose processing unit. So instead, you would buy a sound card and snap that in, and that would do all of the advanced audio processing that you wanted and do things at high fidelity and all that jazz. Now, that has been folded back into smaller chips that are now sitting somewhere on the system board, but it's still a specialized chip that's sitting somewhere on the system board and not the CPU that's doing that work.
Right.
Another big improvement was the TCP offload engine, or TOE, which, if you're counting at home, that's a double acronym. So congratulations, everybody. We've done it.
We did it. Yeah.
And that came along later, and it allowed for you to offload the entire TCP IP stack to the NIC. So now the NIC is handling all of that. And as someone who used this functionality on a VMware platform that used iSCSI for storage, I can tell you that TOE was a tremendous benefit, both for the performance of the virtual machines that were on the host system and also the performance of the attached storage.
Right. And this was when this happened, I was working VMware as well for university, and you could see the difference between nodes. Like if the card had TOE on it versus otherwise identical systems that had a standard NIC, the amount of hosts that they could, the amount of VMs that it could host, factor of 10.
Easily.
From something as simple as the network card is handling the networking.
Yes. And it's funny because it was basically just a checkbox, enable TOE.
Right.
Yes. And I remember there was guidance on, I think it was some version, some flavor of Windows Server, might have been 2003. But there was this thing going around, ways to make your network card faster or something, or some garbage like that. And one of the recommendations was to disable TOE. And it was the same sort of garbage post that also told you to turn off the Windows firewall and disable IPv6.
And just, set your admin account to have no password.
Right, because that slows down how fast you can.
Yeah, it makes the bits go faster.
It sure does. So there were some stability issues with early versions of Windows NT Server, I think, and TOE, and that's where that guidance kind of stemmed from. But obviously, network drivers improved, Windows improved, and so the stability of TOE got a lot better. But VMware,
it was a version 1 problem.
Right. But the problem is, so often version 1 solutions to version 1 problems propagate into version 2, 3, 4, and 5 because it just becomes accepted knowledge. Which that's a whole other topic we don't need to get into. The fact that best practices don't exist. Maybe that's a separate episode. Yeah.
I like it already.
Yeah. Okay. Well, I just got the gears turning. I can see that. So in addition to all the things that I already talked about that were happening with virtual machines and the increase in bandwidth and all that jazz, we also started seeing changes in the ways that the network itself was used. So fiber channel started waning in industries where fiber channel was too expensive, which is most of them. And you started seeing the implementation of technologies like iSCSI, like RDMA, NFS, or even something like vSAN, where you had distributed storage that was being replicated over something like that. All those things, what were they using? They were using the network. So now we had even more packets than ever before, some of which were specialized just for storage. So I don't know if you had this experience, but when I was building ESX hosts, there was a period of time where you would want to have multiple NICs in the host system and have certain ports dedicated to just storage traffic, others for vMotion, others for management, and others yet for VMs. You ended up having, 10 or 12 network adapters on every single host. It was a little untenable.
Oh, you needed to have them bonded for redundancy, obviously.
Oh Lord, and that was so much cabling. It got a lot better when they rolled out 10 gig ports and you just had two 10 gig ports.
Like just what?
That's it.
We're done?
2 cables? What? No, that can't be right.
I'm scared.
Hold me. Anyway, the other thing that happened, and this will be the last one that I'll add in here, was we started seeing the push for software-defined networking, which meant network functions and network function virtualization happening at the host layer. So something like VMware's NSX, where you'd have a distributed firewall, and it would also be doing traffic inspection at the host level. Again, more functions that we're pushing onto networking that needs to be done by a host instead of a dedicated metal box like a firewall or an IDP or something like that. So that's a lot of stuff that happened. So we did introduce, like I said, TOE and also some of the other technologies. the interaction between the CPU and the NIC is governed by both the functionality of the hardware and the software that runs on top of it. So a development to help ease that and offload more functionality to the NIC took the form of the Data Plane Development Kit, or DPDK, that was created and given to the Linux Foundation. I think Intel was one of the founders of that. But it is an open source project, and it's meant to accelerate the processing of packets across various architectures, including x86, ARM, and PowerPC. So you'll see that often, not directly, like you're not going to buy something that runs DPDK, but it's a standard that vendors can use to enhance their network card offerings and the drivers that are written for it.
Right. And it has the added advantage of being basically unpronounceable as a single word unless you want to get quickly demonetized.
Yeah, let's not do that. Well, we're not monetized to begin with. But at the same time that software was being developed, there were new hardware options also emerging, including things like converged network adapters and field programmable gate arrays. So I'll touch on that in a moment, but CNAs, or converged network adapters, are what I tend to think of as the first SmartNIC. And they rose to prominence as blade servers became popular, something that both of us have tremendous amount of experience with. And essentially the idea was it allowed you to take a single physical NIC and split it into multiple virtual interfaces, all running at line speed. So you could take, like we were saying before, a 10 gigabit per second interface and break it into 4 or 8 virtual network interfaces, each with their own MAC address and rate limiting.
Yeah, I mean, just purely from the network design and data center layout of cabling and whatnot, this was a game changer.
It really was. And most of these converged type systems were, like I said, they were blade servers. So all these blade servers were slotting into a chassis, and they had a backplane that was feeding up to some kind of converged network switch that sat at the top of the rack, even though they always told us it wasn't a switch, Chris. It's not a switch. I mean, it's a switch, but it's not a switch.
It's not a switch. It just takes all this traffic and delivers it individually and intelligently. What?
But it's not a switch.
So it's okay.
Sure.
All right.
Now, you could have an actual switch that connected into all those blade servers, but if you were going with an HPE or a Dell solution, their preferred architecture was for you to have the converged network, whatever, that sat at the top, and then you could break that out.
Whatever their thing was called. Yeah.
Right. You could break that out with uplinks, and it also kind of smoothed some of the traffic that was across the blades because it wouldn't have to leave the chassis if you had it correctly configured. So that was nice. The other thing I mentioned was field programmable gate arrays, or FPGAs, and those are essentially programmable silicon. So instead of the traditional ASIC, which, if you didn't know, stands for Application Specific Integrated Circuit, FPGAs can be configured through software to perform different functions depending on the requirements of the user, which means they aren't as fast as an ASIC in terms of raw throughput, but they are way more flexible than an ASIC, because as is implied, ASICs are application specific. So you could think of a GPU almost as an ASIC because it's really good at one thing and it does that one thing, but you can't tell it to do something different.
And FPGAs are good because it means the manufacturing process, you create one generic chip, which can then be used and fine-tuned with the programming that you apply to it, or the firmware, or whatever you want to call it.
Right.
And then one thing that's important about this is you've got to get to a certain amount of speeds where that FPGA performance versus the ASIC becomes irrelevant.
Right. And again, FPGAs are really for, I think the biggest explosion of use with them is with AI and ML type applications that are looking for sort of specialized computation, but it's not worth building a whole ASIC around it because there's time and money that goes into designing a circuit, designing a chip, and then getting that chip created. And FPGA is going to be faster than a CPU because you can program it at the hardware level, but it's not as expensive as developing a custom chip. Which means that you can do even more interesting things with a SmartNIC.
Whee!
So earlier I mentioned the use of direct memory access on a single system to offload processing from the CPU. A technology called RDMA, or Remote Direct Memory Access, that rose up in high-performance compute clusters as a way of one system accessing another system's memory directly without involving the CPU. And that was initially implemented through high-cost solutions like InfiniBand. So if you ever wondered what happened to InfiniBand, it still exists. It's used in these high-performance compute clusters. It's just not used amongst us mortals because it's so ridiculously expensive.
Right. Nor is it really needed.
Exactly. Later implementations of RDMA moved away from the physical solution of InfiniBand and used converged network adapters or regular TCP IP through the standards of RoCE and iWarp, respectively. And RoCE is RDMA over Converged Ethernet, which I think might be 3 acronyms deep.
That's a lot. And it's also, there's no acceptable case for pronouncing ROCE as Rocky.
And yet, that is what the industry landed on.
Say the letters, people. It's not complicated.
ROCE?
SQL.
Oh, geez. So, little aside, I'd never heard of RoCE or iWarp when I went to, I want to say it was Microsoft Ignite 2016-ish, 2015-ish. Sure. And the person who was giving the presentation kept pronouncing it RoCE and didn't actually have it up on a slide. So when I went to try to Google it, boy, did I have a tough time finding it. So the primary purpose behind the implementation, whether it's RoCE or iWarp, is to access storage across the network. So Windows Storage Spaces Direct can use RDMA. I believe vSAN can also use RDMA as its sort of transport and replication layer. It's a way of accelerating that network traffic without getting the CPU involved again.
Right. Because if the CPU had to handle this stuff, it just becomes impossible.
Right. So as all these new features and functions are added to the SmartNIC, at a certain point, it really ceases to become a peripheral and starts to become a system all on its own. So instead of running some simple firmware, the latest SmartNICs actually load up a full operating system that interacts with the primary operating system running on the system board. So you've essentially got an extra computer in your computer, dog. I heard you like that. Oh.
I'll allow it.
Okay. And since we can't have nice things, the name changed from SmartNIC to DPU, for Data Processing Unit, or IPU, Infrastructure Processing Unit, depending on who you ask. Intel calls them Infrastructure Processing Units, and literally everyone else calls them DPUs.
Right, because they're processing data.
Yes. Not infrastructure. You don't process infrastructure.
Right.
Oh my God. Deep breaths. Okay. It's funny because there's a standard that has been put together, and I guess I'll get to this in a little bit, but I could just jump into it right now. The Linux Foundation has started this standard called the Open Programmable Infrastructure Project. And it's trying to set up an open standard for how these DPUs work. And in the actual project documentation, they make sure to refer to it both as DPUs and IPUs because Intel is one of the sponsors.
Right, and heaven forfend, we upset our overlords at Intel.
Exactly. So anyway, I'll get off the soapbox for that and get a new one. So the extra compute and the operating system on the DPU is actually what's being leveraged by AWS's Nitro systems. If you're familiar, when they shifted away from the Zen hypervisor to the Nitro hypervisor for their EC2 instances, the actual Nitro hypervisor runs on a dedicated card inside the box. And it also has additional cards in the box to offload things like network storage and security. So the CPU inside their servers is 100% dedicated to what the EC2 instances need to do. and all the other functionality is offloaded on these DPU cards,
Right.
all of which are custom made by AWS.
Which is, again, another episode in and of itself, but it's kind of insane how razor thin their margins are in terms of, if the system is running at 100%, the CPU is leveraged to like 99% to the VMs. Everything else is handled by one of these external cards. It's wild.
It is. It's awesome. And it's not just AWS that's doing this. Microsoft Azure has been putting DPUs in their servers since 2015, running the AccelNet software, which stands for Accelerate Networking. Very creative. Naming's hard.
Naming is hard.
And that likewise is there to offload the networking and storage functions, because just like pretty much every other cloud out there, the Azure host systems don't have a lot of direct attached storage. They're mostly using network attached storage. Right. And to talk to that, they're offloading that functionality. So it's no surprise that the hyperscalers have adopted this technology. They're usually at the bleeding edge when it comes to anything regarding hardware upgrades or even technology adoption in general.
Right.
For the enterprise, typically not running at that kind of scale, the SmartNIC/DPU revolution has been rolling out at, you could say, a slower rate, trickling in. After all, data centers are not growing at the same speed as hyperscalers, and in some cases not growing at all. And new hardware tends to roll in when the old hardware rolls out, usually on something like a 5 to 10 year refresh life cycle, depending on how stingy the organization wants to be. Additionally, the software to run SmartNICs effectively across the data center is either proprietary and unavailable, like AWS Nitro, proprietary and extremely expensive, like Pensando, or open source with a high level of administrative overhead. When you're a hyperscaler, you can afford the engineers to do all that stuff.
Right.
Yeah. When you're just like a 250-person company, not so much.
Well, I think this falls into that same category, well, different kind, but it's a version 1.0 issue where this is all untested. This is all being run at the highest possible levels because, frankly, it's the hyper clouds that need it.
Right.
You know, if this stuff runs, we were talking before, the CPUs in the hyperscalers run at 99% efficiency. If the CPUs in your personal or enterprise data center are running at 90%, you're over the moon.
Yeah, seriously.
That extra 9% just doesn't mean anything. So why would you spend hundreds of thousands of dollars on this whole complex overlay just to get that 9% that your organization doesn't really need right now?
Right. And it's not just the checkbox of TOE anymore. This is a situation where you have to make an investment in these SmartNICs across your fleet and then have the software that actually configures those SmartNICs across your fleet and continuously monitors and manages those. And you have to have the physical infrastructure that supports all of that. So it's a significant investment. For many organizations, juice ain't worth the squeeze.
Right. Because it's a massive commit. And, I just want to touch on the Pensando thing for a second because, they had this whole idea of, well, they still have it. It's not past tense. It's security as a NIC feature, right? So you sell the switch and each individual port on the switch has its own discrete, basically a firewall in a port.
Right.
Very different, moving the walls a little bit further away, but you again have to commit completely. So if you're doing this kind of networking and this kind of firewalling, all your switches and then overlaying software to manage all of those ports, that's a big ask. And that's a big change in the way that an organization has done it in the past.
Right.
It's not something that you read about in CIO Magazine on Friday and then have implemented by the end of the day on Monday.
No. This typically gets rolled out when you're in a pod type situation where you deliver your architecture, your infrastructure in pods, whether that's at the rack or even the row level. And that's where it makes sense to implement one of these technologies because now all the servers in this row all support the Pensando solution or whatever it is. And then when we're ready to retire the next row, we're going to roll out the same pod, right? that doesn't really work for some organizations. But speaking of software and that side of the house, what's out there today if you are interested in this type of thing? Well, VMware has their Project Monterey, which is their attempt to leverage DPUs for NSX, vSAN, and eventually other portions of the hypervisor. Currently, it only works with NSX, and I actually had a nice chat with one of the folks over at NVIDIA that's in charge of creating the demos and doing the marketing around this. And so NSX is working, vSAN is on its way, and their eventual goal is to offload a lot of ESX onto the DPU and have the same sort of situation that Nitro has, where all the workloads that are hitting the CPU are VM specific and everything else is being managed through the DPUs.
Right. I think that makes a lot of sense, and is also a great path forward for ESXi in general, because what's been happening with ESXi is the software has been continuously loaded up with more features and more requirements and more, and just more.
Yeah.
Which is one of the reasons that they got into such hot water, because all of a sudden it was too complicated to boot off of an SD card, causing the internet to lose its collective mind.
You still shouldn't run it on an SD card in production, but, come at me, bro.
There's no such thing as best practices.
Oh, crap. Well, I use SD cards in my basement, but that's because it's in my basement. And right. SD cards are cheap. Anyway, aside from Project Monterey, OpenStack has drivers using Neutron with Open Virtual Networking, and that also extends to OpenShift, Red Hat's OpenShift, and the ability to leverage DPUs there. So if you're running on-prem, you can do that.
You got options.
You do. And likewise, Microsoft Windows Server 2022 also supports a lot of this functionality, but much of it comes down to the actual network drivers and less the operating system, because it's the drivers that have to do the chattiness with the DPUs to tell them to offload this functionality. So it is kind of a marriage of the operating system, the drivers, and the hardware, which means it would help if we had an open standard for how these DPU things should work anyway, which is what the Linux Foundation has started, called the Open Programmable Infrastructure Project.
Or OPIP. Ugh. See how dumb it sounds when we force things to be pronounceable?
It's really dumb. So the project has the overall guidelines of defining what a DPU and IPU are, delineating vendor...
Because the name stinks. Get it?
All right. Well, I'm just going to say DPU from now on. Intel can suck it. Or they can sponsor us.
Don Intel that you said that.
Yeah. They also are there to delineate vendor-agnostic frameworks and architectures for DPU-based software stacks, enabled creation of a rich open-source application ecosystem, integrate with existing open-source projects, and create new APIs for interaction with and between elements of the DPU ecosystems. That last one's probably the most important part, is to have...
Yeah, because that's how you get multiple vendors to talk to each other and systems to actually work.
Exactly. And the idea, hopefully, is that these APIs would be open and free to use to encourage this cooperation between vendors and a little bit of competition.
Right. The word open is super important for any of this stuff.
Right. Broadcom's involved somehow, so we'll see how well that goes. Other major players in the industry that are backing this OPI project include Intel, NVIDIA, and Marvell. So honestly, the first two are the biggest players in the industry anyhow. So the fact that it has the backing of the two biggest in the industry is kind of huge. Intel, they have their IPUs, and NVIDIA has their Bluefield technology, which I think is in version 2 right now, but version 3 of Bluefield is coming soon. And it's going to bring even more capabilities, especially for these kind of offloads. As the project matures and standards begin to emerge across the hardware platforms, it's going to flip-flop to software innovation to take over. And I think we'll see adoption of DPUs in the enterprise and probably at the edge. Honestly, most of the adoption is going to be likely driven through VMware's Project Monterey and its support for OpenShift. Those seem to be, as far as the enterprise goes, the big platforms for adoption.
Yeah, I mean, those are the two. I mean, OpenShift has, I think, a lot of potential.
It does.
I feel like they've been, in version 1 for it's the entire existence. So if they can make that next step, and if enough people are nervous about VMware, which, I get,
Yeah.
There's an opening is all I'm saying.
There is an opening, and there's also an open source project to use OpenShift or Kubernetes more broadly to manage virtual machines in addition to pods. I think it's called KubeVirt. Very simple, Cube, VM, KubeVirt. You get the idea. And that could be the missing piece of the puzzle to extend OpenShift and other Kubernetes flavors out beyond just containers and pods. So we'll see what happens with that. But yeah, that people are definitely starting to look for alternatives to VMware over the concerns of what's happening with the acquisition. One last interesting point, and this could lead into another future episode. I think we're up to 3 now.
3 or 4, yeah.
Yeah. There's another disruptive architecture on the horizon that could further confound what it means to be a server. Man, what does it really mean to be a server?
Have you ever really looked at your motherboard?
Wow. It's called CXL. And I think we've mentioned that technology before on the show. And Chris, you and I were part of an Intel presentation where they were talking about CXL. And I think we were both a little excited about it.
Yeah, I don't know. Yeah, we definitely don't have time to go into it in depth, but really they're just, as we get to, I want to say version 3.0 of CXL, because 2.0 is what's out now.
Yeah.
You're going to be able to start disaggregating like everything.
Everything.
And that's not an exaggeration.
No. So I will simply say that the line between peripherals and the system board is about to get even fuzzier, and our conception of what it means to have a server is going to be challenged, and I'm very much looking forward to that.
Yeah. It's the dream of a composable infrastructure being realized.
For real this time. For
reals. Realsies. No takebacks.
Maybe a little take back. I'm still
like
mad
one
about
take
OpenView.
Back. You get one.
Okay. Lightning round?
Lightning round. Proton Mail suffers second outage in 8 weeks, and users are not amused.
Are you a user, Chris?
So, here's the thing about email. When someone sends one, you expect it to arrive. Maybe not instantly, but I think there's a reasonable expectation that an email is received, what do you think, 5 minutes tops after sending?
And that is a stretch,
So there's 2, I think, delivery times that are reasonably understandable to the general public, and they're roughly categorized into longer than 5 minutes, which is bad, and not at all, which is way worse.
A little bit.
Proton.me, which is the official name of the organization, security privacy vendor of some renown, has had 2 problems with their Proton Mail product over the past month and a half. Back in July, they had a real bad issue that fell squarely into the emails not being delivered camp, which is catastrophic for a company that, again, is designed to deliver email. And then just this week, they had another outage that delayed emails an unknown amount of time. Now, according to the company, both incidents were related to internal teams doing upgrades that were not tested and vetted, thus causing the problems. Proton went to great lengths to assure users that no data about their accounts, at least, was ever in danger of being lost. However, as we said above, an email delivery service that does not reliably deliver email is a problem.
Yeah.
Plus, many users reported website access problems during both of these incidents. This is also a problem if you primarily use the website to read the email.
Mm.
And don't scoff. I hear scoffing. Lots of people do that.
I mean, that's how I interact with Gmail most of the time.
Right. What's funny is that prior to this rough stretch of some weeks, Proton had a reputation for reliability for the many, many years they've been operating. The big change recently has been unifying all of their products under one banner, the Proton.me that I was alluding to earlier. It leads this author to believe that the Proton team perhaps underestimated how difficult the unification would actually be. Perhaps this second incident happening in such a short time frame will cause Proton to think about slowing down with features and getting back to focusing on reliability. After all, we know what people would think about a third incident.
That's enemy action, right?
Correct.
So speaking of big changes and unification, why is Ethereum always preparing? Just merge already. This is a lightning round article, so I'm going to do my best to rein in the ridiculousness of crypto bullshit. All blockchains require a consensus mechanism between independent nodes. It's the way that new blocks are added to the immutable chain. There are two well-known mechanisms, proof of work and proof of stake. Both Bitcoin and Ethereum were founded using proof of work, meaning that each mining node in the network races to perform a complex mathematical problem that is either computationally or memory intensive. Putting in the work, as it were. When a node completes its work, it is verified by the other nodes in the network, and assuming there is a consensus, the block is added to the chain. Because the work is expensive, the thought goes that only legitimate nodes will participate, and their reward for participation is a fraction of the newly minted coins that come with doing the work. It also means that miners use a frankly preposterous amount of power to do their very, very dumb work. Ethereum founder Vitalik Buterin has long been aware of the problem and has wanted to move Ethereum to proof of stake consensus, which instead of solving stupid puzzles, proof of stake nodes have to provide a certain stake in the system that they will lose if they fail to adhere to the rules. The process of moving from one consensus algorithm to another has been in the works for years now, constantly pushed back by concerns in the community over how it would work and the potential disruption, and also some of them just don't like proof of stake. It's a fair point. The mechanism finally agreed upon was to start up a separate chain called the Beacon chain, set that up to work as proof of stake, and then merge it with Ethereum later, with the original Ethereum forming the execution layer of the platform and the Beacon chain becoming the consensus layer. Despite constant setbacks, it appears that mid-September will be the merge date based on publicly available data on both chains and chatter amongst the Ethereum developers. Will any of this make crypto a worthwhile endeavor? Probably not. Will I finally be able to buy a GPU at a reasonable price? Most likely. And that's the actual good news. You're welcome.
2-year-old iOS bug that renders VPNs unreliable, still not fixed, says researcher. iOS has sort of a problem. Okay, well, actually, let me back up. From Apple's perspective, there's no problem. Everything's fine. But security researcher Michael Horowitz claims, with evidence, that VPNs running on iOS leak data. He tested this with multiple VPN products and multiple iOS products, so it's not a specific or unique situation. What is super frustrating is that Proton VPN reported this issue publicly in March of 2020, and it is still not fixed. One of the reasons it might not be fixed is, as I said earlier, Apple claims there's no problem. Basically, the idea here is your phone is a device. You create a VPN tunnel on your device. All of your traffic is supposed to go through that tunnel. All of it. No exceptions. But apparently on iOS, this breaks down over time, allowing data to leave the iOS device without traversing the VPN. Apple does acknowledge the issue, at least they did in 2020, but again, claims that it's fixed. Proton called bullshit and made the flaw public after it became clear that Apple was not interested in fixing it 100%. It seems like there is a certain amount of convenience versus security going on here, with connections established before the VPN remaining open outside the tunnel as well. But there's also some confusion internally in iOS. Apple's documentation clearly states that VPN split tunneling is not possible on iOS. Yet, Apple services are some of the worst offenders leaking data outside the tunnel. My guess is that other data is just following that same path. This, as the kids say, is frustrating.
Beware the unused account, says Mandiant. Cybersecurity outfit Mandiant has issued a new warning about a way to circumvent multi-factor authentication. Well, that's not entirely accurate. Attackers aren't actually circumventing MFA, they're enrolling in it.
So that's good.
Yeah. Well, not really. Let me explain. When someone is hired, their user account and credentials are usually provisioned ahead of time. And usually they are issued a username and temporary password, which they will be prompted to change on first login. Assuming that MFA is enabled and enforced, the user will also be prompted to enroll in MFA on that first login as well. Since we are in a remote-centric world, many accounts are created using a public identity provider like Google Auth or Azure AD, and initial enrollment is not performed from, let's say, a trusted network. Thus, there is an entire period of time between the account creation and when the legitimate user actually enrolls, where an attacker could find the account, crack the temporary password, and enroll an MFA with their own devices. Worse yet, sometimes accounts are created and the legitimate user chooses not to join the company. Hey, it happens. And now the account may hang out for an indeterminate amount of time as a tempting target for hackers. The way around this type of attack? You could issue new users an actual MFA token, like a YubiKey or something similar. You should definitely have a process where the account is available, but disabled until the user actually starts working. And the temporary password should be complex enough to foil most cracking attacks. Ideally, you would lock things down to a trusted system or trusted networks, but as we've already discussed, that's becoming less likely. At the very least, now might be time to audit your existing user accounts and disable those that are idle or unused for a certain period of time.
In the early 2000s, the Janet Jackson video for the song Rhythm Nation would crash computers. This one, posted from the back in my day, things crash for absolutely no reason too department. Playing videos on old computers used to be a dicey proposition. Ignoring the fact that the processing power required for rendering the audio and video simultaneously was a challenge, some laptops seem to have other, less easy to diagnose problems. This week, Microsoft software engineer Raymond Chen recounted one such issue. Playing the Janet Jackson video for Rhythm Nation, laptops containing, quote, a certain 5400 RPM OEM drive would crash. So, this is not, an attack on taste. This is not criticizing Janet Jackson. It turns out that the song had several moments of sustained tones around 84 and 1/8 hertz.
Huh.
This, it would seem, was the resonating frequency for those 5400 RPM hard drives. Since hard drives mounts themselves were not dampened, because why would any self-respecting manufacturer do something crazy like float the drive on 5 cents worth of rubber spacers, the internal components would thus vibrate, eventually causing data reads to fail and the operating system to crash. Now, to be fair, this does have the faint ring of an urban legend to it. And Chen is declining to name the OEM or the other engineers who identified this issue way back when. However, there are others on the interwebs shouting that the same thing happened to me. So I'm going to firmly categorize this one as plausible. After all, sound effects matter. Surely we all remember Sun engineer Brendan Gregg causing observable latency in a disk array by simply shouting at the disks.
I have never
That's a
seen
thing.
that.
Look it up.
I am excited to click on that link later. So you've given me something to hope for, Chris. Google Cloud Armor fends off 46 million requests per second DDoS attack. Distributed denial of service attacks are nothing new, but the volume and intensity of the attacks continues to grow at a frightening pace. The latest record holder was experienced by a Google Cloud customer on June 1st, where the DDoS attack ramped up to an astonishing 46 million requests per second. Google's blog puts that in context as the same number of requests Wikipedia gets daily, but in 10 seconds. This attack is also 76% bigger than the previous record holder reported by Cloudflare just a week earlier. Clearly, the DDoS bot networks out there are becoming more sophisticated and robust if they can ramp things up so tremendously in the period of a week. One might worry that attackers are testing their limits before going after more sensitive targets. Boy, it's a good thing our geopolitical situation is super stable at the moment.
Everything's absolutely not on fire.
It's fine. Lucky for the site in question, they were behind Google's Cloud Armor service with adaptive filtering, which was able to bring the attack to the customer's attention as it was ramping up and give them the option to add a dynamic rule to filter out the bogus requests. Gentle reminder to those who run a website of any size, I highly recommend getting yourself behind a CDN or DDoS mitigation service of some kind. Many are free for smaller sites and quite affordable for enterprise workloads.
Just do it, you guys. Just do it.
Yeah. Wait, no, that's somebody. Oh, crap, we're sued. Hey, thanks for listening or something. I guess you found it worthwhile enough if you made it all the way to the end, so congratulations to you, friend. You accomplished something today. Now gallivant with those you've come to know and love. Find yourself a soft serve ice cream buffet and remember to take your Lactaid. You've earned it. You can find me or Chris on Twitter at Ned1313 and at Hainer80 respectively, or follow the show at chaos_lever if that's the kind of thing you're into. Show notes are available at chaoslever.com if you like reading things, which you shouldn't. Podcasts continue to be better in every conceivable way. We'll be back next week to see what fresh hell is upon us. Ta-ta for now. Made it through. I did it.
Just barely.
Just barely.